if you have developed any kind of negativity towards mathematics, you will not be able to learn physics. Now you must be thinking, who starts video with a negative comment, right? Apparently I do. Anyway, why I'm saying this is because in 11th and 12th physics, and any physics even after this, requires mathematics to a great extent, right? So if you have developed any kind of fondness towards physics, it's about time that you make do with math. And mathematics actually is very simple. All it takes is practice mathematics, right? Anyway, enough about that. Now about the topic of the video, calculus is one such tool which becomes immensely important to understand to any problems in physics, and it will stay with you even if you end up in engineering or you pursue basic sciences. It will stay with you, the derivatives, right? So understanding that is very important, and obviously we'll be needing derivative tools and integration tools, calculus basically, for our 11th and 12th physics, right? So yeah, so let's try to understand derivatives. But before we actually get into derivatives, let's try to understand this first. Like, what is a mathematical function? What is a mathematical function, right? So you might have come across these equations in your junior classes already. Equations like, I don't know, say y is equal to 3x plus 1. Equations like y is equal to sine theta, right? And or theta is a variable, or we'll mostly be using sine x to define mathematical function. Or y is equal to 3x squared plus 2x plus 1. The third one right there is a quadratic equation basically, right? If not anything, at least you for sure have come across this equation right there. Don't worry about all these. If you have not seen these things, don't worry about all that. And quadratic equation, yeah, obviously you have seen quadratic equation, but don't worry about this trigonometric function and all that if you have not come across that. Anyway, so I'll take the simplest example here and try to define what this function and all that is, right? So let's try that. So I have chosen an equation that we are all familiar with. Say y is equal to 3x, and you all have drawn these graphs in your junior classes, right? They'd ask plot the graph of y is equal to 3x plus 1, right, giving you a graph sheet or whatnot, right? So let's try that. And if I remember it right, you'll start with the x variable first. You'll choose some random values of x variables, and based on that you will calculate the y variables. Let's try that. For example, let's choose x equal to 1. If x is equal to 1, what will y be? I don't know. Y is equal to 3x plus 1, right? So it will be 3, x is 1 in this case, plus 1. So y will therefore, you will decide, therefore y is equal to 4. Alright, so for x equal to 1, y should be 4. Then you will choose something else. Say x equal to, I don't know, 0 you will choose, right? So y is equal to 4 is 1. Then again you'll do the same calculation once again. So y is equal to 0. So 3 times, instead of x you'll substitute 0 plus 1. So y will be 1. So you'll just write it over there. And then you'll choose some other data, like, I don't know, what x equal to, let's say 2, right? So for that you will find the value of y is equal to 3 times x is 2. Basically I'm using in all these that equation. So 3 times 2 plus 1, which is 7. So alright, I'm getting these values for y. So for 2, y happens to be 7. Let me try to plot this on the graph now, right? So I have, for x equal to 1, this is x equal to 1 right here, y happens to be equal to 4. So it's somewhere that point right there. This graph is not really accurate, but yeah, approximately I've drawn something. For x equal to 0, x0 is here, over here on the x-axis, the 0, and at that point y happens to be equal to 1. Alright, great. And for x equal to 2, y happens to be 7. So x equal to 2, y happens to be equal to 7. So I'll roughly that point there, right? And your teacher must have told you in junior classes that you need at least 3 lines to draw any line on a graph, right? So let me try to connect these points, and if I do that, I'll roughly get this line, and you can extend it as much as you like. So that right there is your straight line, and it actually extends to as much as you like. I'm not here to teach you graphs and all that, but you know, the point I'm trying to make here is that I think it is always that you choose the value of x, and based on that you end up calculating the value of y, right? You choose value of x, and then based on that, value of y is decided based on whatever equation was given to you, right? So in this case it happened to be y is equal to 3x plus 4. Therefore, in this equation y is equal to 3x plus 1, since you decide x first and based on that you end up deciding y, right? Therefore, the x is called independent variable. Independent variable. It's called independent variable, and y, obviously, which I've guessed it right, is called dependent variable. It's called dependent variable. Meaning for different values of x, y will assume the respective values based on whatever the equation is. Now in this case it happened to be 3x plus 1. Maybe tomorrow they'll give you an equation like this: y is equal to 4x minus 2, or to make things little more interesting, they may give you y is equal to 2x squared plus 1. You never know, right? So all these equations that I've been writing are mathematical function, or you never know, y is equal to sin x plus cos 2x, right? I just complicated that, but anyway, in all these equations, x usually, in mathematics we usually take x as the independent variable, right? The value of which you will first decide, and based on that y goes on assuming different values. All right, so such an equation is called mathematical function. It's called mathematical function. So to simplify this, what I can just summarize these things in a simple statement, something like this: that a mathematical function, let's say this is a mathematical function, always ends up taking some kind of input. It takes in an input, and gives you an output. And in all the equation that I just discussed, over there the input was all the values of x that you could possibly give, right? And output would be all the y values, right? So input is usually the independent variable and output is the dependent variable. For example, in this case, y is equal to 3x plus 1. In this case, x is the independent variable or the input, and y is the dependent variable or the output. But there is just one small different way in which we also usually write y as. We usually end up calling, since y depends on x, we say that we also can say this something like this, that y is a function of x, is a function of x of the independent variable, right? Therefore we usually can also write this as f of x. F stands for function, so function of x is equal to 3x plus 1, right? So it's as good as writing y is equal to 3x plus 1, and this function could be anything. A function of x could be anything. Someday the function of f of x would be, function of x would be, I don't know, just sin x, or a function of x would be, don't worry about all these things, but for now I can just write it as log x. That is for logarithm. That and all we'll study as we continue. But yeah, I hope you're getting an idea of what a function is, right? So that's what a function is. But sometimes equations may look like a function, but they actually are not a function, right? Let's see them. So what are not a function? Let's try to understand that. As we have seen, that a function is something like this, which takes an input usually x, and gives you an output, usually f of x. I'll be mostly using f of x from here on, not y, or y, you can stick to y also, but yeah, mostly we'll be using f of x. Fine, that's what a function is. Then what is not a function? What is not a function? Let's look at this expression, for example. You have an equation that looks like this. Say x squared plus y squared is equal to, I don't know, is equal to 4. Okay, and you may not be aware of it by now, but this is actually equation of a circle. You don't have to worry about that. Just believe me when I say this, that this is an equation of a circle, right? So clearly looks like I have x, I have a y, so this could be a function, right? But let's see whether it actually is a function or not. This equation that you see on the screen, like I said, is equation of a circle of radius 2. I'm sorry, I ended up drawing it as 4. So let me make it that equation. So I'll just change it to 16. All right. So this is basically x squared plus y squared is equal to 16 is basically equation of a circle of radius 4, because standard equation of a circle is x squared plus y squared is equal to r squared, where r is the radius. Anyway, so you have that, right? This is a circle. Let me try to find the value of, let's say for now, independent variable usually is x, right, and dependent variable usually is y. So let me try to evaluate that. Let me put x value as, I don't know, let me choose the value of x to be 1, right, and let's see what goes on if that happens. Let me choose x to be 1. If x is equal to 1, I can in fact evaluate y from this equation, right? So I'll substitute x equal to 1 in this equation. So I'll get 1 plus y squared is equal to r squared, basically is 16, right? So it's 16. So if you simplify this, you'll get y squared is equal to 16 minus 1, which is 15, or y is equal to plus or minus root of 15, right? So root of 15, it is little less than 4 actually, root of 15 is, right? So, and this is my 1 2 3 4, this is like 1 2 3, and that right there is 4. You get the idea, right? So for x equal to 1, y actually assumes two values. One value is this is my 4, this right here is 4. It actually assumes two values. One is this value and one is another value here on the negative side of it, right? So it is taking two values. One is, don't look at this as 4, it's little less, it's root 15 actually, which is little less than 4, and then this value. So for a given value of f, for a given value of x, if y assumes two different values, then such equation is not a mathematical function. It's not a mathematical function because it is taking one input and giving two outputs, right? So if a function takes one input and gives two output number 1 and output 2, and even more than 2, sometimes that also happens. If the output is more than 1 for a given input, then such equations are not mathematical functions. So don't let them mislead you. Anyway, so that's the definition of mathematical functions. And function basically is anything that depends on one independent variable, right, and gives you a single value for a given independent variable. So yeah,